cultures. On the one hand, they attend a large, modern, very culturally diverse, secular university where science is taught hard, fast, and technical, with little class time devoted to reflection on the meaning of science and the conflict that a scientific worldview might have with traditional ideas. It's certainly not my intention to change anyone's worldview per se. I'm not going to convert you. But on the other hand, we have failed as university educators if you do not emerge from university with a different perspective. I mean, how can one learn about probability theory, the genetic basis of life, the intricate molecular mechanisms of cells, development in the sense of embryology, and yes, evolution, and not have a changed view? And so I view this debate as an opportunity to explore some of these conflicts. And as pummeled as I may be at the end of the debate, I'll be happy if I believe some of you have left with some understanding of the nature of the differences between the scientific method as philosophical system and theologically based philosophical systems. Actually, the college professor wells up in me and is telling me that I should probably give you a pop quiz at the end of the class. And I must say that Kent's introduction certainly fans those flames because he portrayed a very incorrect statement about what science is. What I see as the foundation, the key to understanding this conflict, lies at the various deepest levels in the philosophies of science and religion, that is, in the metaphysics of the contrasting philosophical systems. So what I'm going to say for the next few minutes is going to sound like Philosophy of Science 101, although unfortunately our students rarely take such a course. I also point out that I use the word metaphysics not in the sense of listening to New Age music, burning incense, and eating vegetarian pizza, but rather as that area of philosophy that deals with first principles, with those things that cannot be deduced or proven to be true. We simply take them to be true by assumption or supposition. We might say, for example, let's suppose that the geological forces of erosion, volcanism, glaciation, et cetera, that we see operating today have always worked in the same way. What could we learn from this? What would this lead to as a set of inferences about the Earth's history that may seem sensible? We can't really defend these assumptions, and Kent has pointed this out. We can't prove it to be true. We can't simply make it a part of our, we can simply make it a part of our philosophical system and see how successful that system is in leading us to new discoveries. This is essentially what geologists did in the late 18th and 19th century, and this led to the very first inkling that the Earth must be a pretty old place. At the base of science, I think, is a very small and clear set of first principles, the metaphysics of science. And that leads to the so-called scientific method. If I could have the first overhead. This is one scientist's statement as to what scientific method is. He says, in general, we look for a new law by the following process. First, we guess. Don't laugh, it's really true. Then we compute the consequences of the guess to see if this law that we guessed is right, what it should imply. Then we compare those computation results with nature, we say, to experiment or experience. We compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make any difference how smart you are, who made the guess, or what his or her name is. If it disagrees with experiment, it's wrong. That's all there is to it. This short, whimsical, even facetious statement is actually a fairly concise and complete statement of the scientific method, as simple as it is. One of the most interesting phrases in Feynman's description is, quote, "First we guess." A very confusing issue we must deal with straight away is that of what it means to say evolution by natural selection is a theory as opposed to a hypothesis or fact or even a guess. Nowadays, scientists pretty much use the words theory and hypothesis interchangeably, and even the words conjecture and yes, the word guess as synonyms for theory and hypothesis. Steve Gould made this very important point in his talk last week when he pointed out that there is no hierarchy where guesses are promoted to hypotheses and hypotheses elevated to theories and theories elevated to natural laws. They're all really guesses which have been tested against empirical evidence or not tested. And if they've been tested, they've been falsified or not falsified. But it is equally true that a guess, hypothesis, or theory that has been tested and not falsified has to some extent been corroborated, that is found to be useful in explaining some sets of observations and pointing to new experiments that we might do. In that sense, some theories are better than others, and in that sense, if someone were to ask me if evolution by natural selection were a fact, which often happens, I would say, of course not. But it is not merely a theory. It is one that has withstood test after test after test without being falsified. I repeat, without being falsified. It is in the secular pantheon of scientific theories, that is natural selection theory, along with quantum mechanics, relativity, atomic theory, continental drift, and a few others. But none of these theories are facts. Here are what I think are roughly the first principles of science, if we could have the next overhead. The first one, Kent referred to somewhat derisively, that natural law acts the same way at all times and in all places. This is a first principle of science. It's not something that we can prove. This is the idea that I alluded to above that seems to have been derived from the ideas among geologists of the 19th century, and it's the idea that they called uniformitarianism. Implicit in this is that science doesn't deal with miracles, because miracles by definition involve circumstances where natural law is set aside. Now, conceivably, science could determine whether a miracle had taken place, but I even doubt that. For example, someone might make the claim that so-and-so had arisen from the dead, and we might apply a scientific analysis to determine that the person in question was, in fact, once dead and was now, in fact, alive. But even here, we would want to be very wary of a possible hoax, substituting, for example, a live identical twin for the dead person. So even here, I would want to see maybe 3 replicates with proper controls. And this is what religion